So I'm John, and I work between chemistry and the BCI on a material called conjugated microporous polymers with an application of hydrogen storage. Remote would be handy. So what's the deal with hydrogen? People are really interested in it because probably don't have to explain to anyone in the room that fossil fuels are bad, and we've decided universally we should probably try and get rid of them. And hydrogen is a very good energy vector and might be suitable for this. We can generate hydrogen in very green manners, biomass, geothermal, and it has a very impressive gravimetric energy density, much more than traditional fossil fuels, maybe 3 times as high. The disadvantage is it's very low in terms of volumetric energy density, and if you go buy a commercially available car currently, that's the Toyota Mirai, they kind of offer about 5.7 weight percent in terms of energy capacity, hydrogen energy capacity, and that's pressurized at between 700 and 1,000 bar, and that's using a very expensive carbon fiber tank, type 4 tanks they call them. So there's an alternative phenomenon we can exploit called phys absorption, and that's where we're using a surface of a material to interact with this hydrogen and sort of hold it. And what we're trying to do is engineer materials with these very small holes so hydrogen will compact and feel this potential and this interaction between the surfaces in what we call pores. So we're looking for something that 2 nanometers or 2 times 10 to the minus 9 meters. When anything larger than that, you don't really see the effect anymore. The hydrogen can't really densify and pack, and you fail to see any benefit. So what a conjugated microporous polymer is an organic material. It was first reported in 2007 by a chap in Liverpool, and my primary supervisor reported something in 2014 with this structure. This is the type of chemistry you can do a cross-coupling reaction, and it was the first CMP made with this type of chemistry. And that's what it looks like in SEM. And you can see the 2 extremes of this experimental series that I did. You've got this, on the left, you've got this more agglomerate type nanoparticle system, and on the right, you've got this very voidous aperture. You can sort of see the pores appearing in the SEM, and that's how we like to imagine the CMP, that little structure up there, like a sort of cross network of organic material. So SEM, we're looking at 10 to the minus 6 meters. To go smaller than that, we need to probe with nitrogen gas, and we can use the isotherms on the left and extract data from there using commercially available kernels. What I want you to see in this image is basically the increase in volume in the pores below 2 nanometers, which is what we're aiming for. Just thinking back to that diagram on the last slide. We can probe directly using small angle X-ray scattering, and there's a lot to digest here, but I just want you to take away that the closer that number, the N term comes in that inverse relationship, the more spherical and solid the particles are becoming. So the lower the number, the more open they are. We can dose with hydrogen and get some storage measurements, and we see the sort of same trend with the micropore volume. We see the same trend with the hydrogen storage capability. We can test at higher pressures, make a correction that sort of exists as an artifact of how we take the measurements, get the total hydrogen in the system, and we can sort of make an estimate of volumetric density. And if you look at that graph on the far right, you'll see that that is hydrogen on the blue line without the material. The orange line is the volumetric density of hydrogen confined within the material at the same conditions, so we've improved it significantly. So take away from this one is more hydrogen in the same space using the material. And why is this in the composites industry? So, department. All of the materials are, these porous materials, they all exist as powders, so that kind of makes it hard to process. What we've done here is included the CMPs in another special type of organic microporous polymer, which is quite a special one because it's castable, and we can make these membranes and these films benefit from both systems in a hybrid system. And yeah, I think that's it. Just thanks for listening.